All right, so section 2.6. Let's take a look at the questions. I'm probably going to be going up and down. Y equals the square root of x. If we look at our graphs up here, the square root of x is graph D. I'm going to make this very small so I can get the whole picture in there. It's going to be really tough on me to see it, and you probably. So y equals the square root of x is graph D. These are square root graphs. They start at one point and they go on forever. Do you see there are no x values or no negative values? If you put a negative into square root, you get an error on your calculator. X to the third, if it has an odd power, these are x to the third graphs. Y equals x to the third, y equals x to the fifth. Any odd power, it's dealing with this graph. So let's look at the domain and range of these, because now they're asking for domain and range. So if we look at the domain of this graph, domain, what can x equal? Do you see the domain is the left side, the farthest left, and the farthest right. The domain here, the farthest left, is 0. The farthest right, it's hard to, they don't show the arrow, but there's an arrow there, even though they don't show it. It goes on forever to the right, so it goes to infinity. You can never touch infinity. So the domain for this graph is from 0, the far left, and it goes all the way to infinity, the far right. Here, for this one, they want to know the range. The smallest part was down, the lowest part, these are negative numbers, go down to negative infinity. The highest part of the graph go up to positive infinity. So the range for the second one is negative infinity to positive infinity. All righty. Step 3, or question 3 says, which is not the graph of a function? Which ones are not a function? A, B, C, or D? Anybody know which ones are not a function? Which
B.
one? B is not a function. It touches twice, and that's the only one. It touches once. Do you see any vertical line I touch only crosses one time? Yes, it's a function. Yes, it's a function. Yes, it's a function. No, it's not a function. So B, graph B is not a function. And I already told you what is its equation. When it's on its side, then the y is squared. So when a graph is on its side, then it's x equals y squared. If it were this, y equals x squared, the graph is a parabola. It's a U shape going up. So that's what a y equals x squared graph is. This is an x equals y squared graph, the parabola on its side. And then there's one more question. Part 4 says, which function increases the entire time, the entire domain? Which function increases the entire domain? A, B, C, or D? It's hard to see what D just goes up. It goes up and to the right. So D increases. But so does A. It's really hard to see. Do you see we're going up? It's hard to see we're going up, but then we're still going up. It's really hard to see. It almost looks like it's constant at that point, but it's not. The graph is not constant. It's always going up. We get this negative 0.1, then 0, then 0.1, 0.2, 0.3. So A and D is the answer. A and D are the answers for number 4. Which graphs are increasing the entire time? From left to right, A and D. All right. Determine the intervals in which the domain is continuous. Continuous means no holes. There are no holes in the graph. And this goes on forever. So it's continuous. And you see that it even marks it and tells you that x value is -3. So from -3, it's a bracket because it's filled in. And then this graph has no holes in it. Goes all the way to infinity. So it's continuous from -3 to infinity. Now here, it's really hard to see. I think I better make it bigger now. I think we can make these bigger now. Number 6, there is a hole there. It's hard to see. There's a hole. So this graph is continuous. Starts at -infinity. Do you see? And the graph is going up. It stops right there at 1. There's a hole there. It's not continuous anymore. It stops. So it goes from -infinity to 1, and then it starts up and it's continuous again on the other side of 1. We're talking about the x value of 1. The other side of 1, it starts up again and goes all the way to infinity. So, and we always put a union symbol here. So the domain is continuous, and you can just call it, by the way, continuous means domain. The domain is continuous from -infinity to +infinity, except for this little hole right there at x equals 1. So it's continuous from -infinity to 1, then from 1 to +infinity. All right. There's all kinds of different things we are learning today. It's a lot. And 7 and 8 are no exceptions. They're a lot. Oh, so these are the last 4 problems we have to do. 7, 8, 9, and 10. Yes. All right, so these are not difficult, but for some reason, people miss these on the test a lot. And if in the homework or the test you see something, these are called piecewise functions. They have different pieces to them. I want you to see this. This is the actual function. And it really is y equals. Do you see? That's a y equals 7x plus 2. Then we have a y equals 7 minus 7x. Then we have a y equals 3x. I want you to show there are 3 functions here. But you only use the top function when x is less than or equal to 0. Do you see? If they say x is less than or equal to 0, you only use this. If x is between 0 and 7, you use this, and if x is greater than 7, you use this. So depending on what x is, you use a certain function. So do I use which function do I use to find this answer? By the way, what am I looking for? It says find the requested value. What am I looking for? It says find F8. What does 8 represent? What letter? Thank you. Somebody's typing something in there. Well, 8, wait, no, be careful. 8, remember the way we write down a function, whatever's in the parentheses is the x value. Whatever it equals is the y value. This whole thing equals y, do you see? But whatever's in that parentheses is the x value. Whatever's in that parentheses is the x value. Okay, so we know x equals 8. And find the requested value, well, we need to find out what y equals. If we got x, we need to find y. And these are all y equals, y equals, y equals. Which one do we use, top, middle, or bottom? Which function do we use? Anybody know which one? You can only use one. Yes, the last one. I don't know what's that, top, middle, or bottom. But yes, do you see we have to use this function because x equals 8. 8 is greater than 7. You see, is 8 between 0 and 7? No. Is 8 less than 0? No. We have to use the bottom one because 8 is greater than 7. So we have to use this one. Y equals 3x. You see, we have to use that one. And we have to plug 8 into the x. Y equals 3 times 8. On my calculator, the answer is 24. So this answer is 24. When x is 8, y is 24. That's it. All this stuff just to do one little thing. So let's try the next one. So this next one, x equals 6. Which one do I use, top, middle, or bottom?
Middle.
Somebody said the middle. Anybody agree? I need one person to agree or somebody disagree.
Yeah, the middle.
Yes, because if you put 6 here, is 6 less than 6? No, it's not. 6 equals 6. So if you put 6 in here, 6 is less than or equal to 6. Yes, we're going to use the middle one because the equal signs are here. So 6 fits in the middle. Do you see? 6 fits in the middle because it's equal. 6 is less than or equal to 6. That's true. So we're going to use the middle one, y equals 5x, and we're going to plug 6 into y equals 5x. Y equals 5 times x, and we're plugging 6 into the x. So y equals 5 times 6 is 30. The answer, f of 6, when x is 6, y is 30. So piecewise function, only one of them is going to be correct. For each number, only one of these piecewise functions is correct. All righty. Let's move on to the next one. Is there any other questions they're asking? Nope, that's it. Oh, they want us to graph this. Oh, no. Please don't make me graph this. Oh, we have two that we have to graph. Okay. Yeah, I'm not a big fan of the graphing these, but we'll look at this. So I'm going to split this. Luckily, there's only two functions we have to graph. Watch what I do. Look at the domain here. X is greater than or equal to 1, and X is less than 1. Do you see? X is less than 1, X is greater than or equal to 1. So I'm splitting this into two pieces at X equals 1. I'm going to split this right down the middle at X equals 1. All right, so we have two functions. Here's one function, y equals 3. Here's the other function, y equals -1 minus x. So we have two functions here. I just want to make sure we know this. Well, if I do a t-table for each one, y equals 3, when you don't have an x, look at the first one. We don't have an x value. You can plug anything you want. If there's no x that just says y equals 3, you can plug anything you want. I'm going to plug 0. Y equals 3, I'm going to plug 1. Y equals 3, I'm going to plug 2. So I'm going to do this graph in blue. This is going to be a blue graph. Y equals 3 at coordinate 0, 3, at 1, 3, and 2, 3. Now look at this graph. This graph is only if x is greater than -1. So you can this graph, this is the line. You connect the dots and there's our line. However, this graph is only for on the right side. X is greater than 1. Do you see on the right side of my 1? The left side is not in the domain because it says we're only doing y equals 3 when x is greater than or equal to 1. Here's the 1 value. So it's equal to 1 and greater. That's what the graph looks like. Now we have to do this graph on the other side. I'm going to plug an x and a y. Somebody tell me an x value. Hey, now when you tell me an x value, the easiest thing to say is 0, and I'm going to do this in a different color. I'm going to do this in green. So plug 0 in. I'm going to do y equals -1 minus x, and I'm plugging 0 in there. -1 minus 0 is still y equals -1. That's 1 point. And this is a linear equation. It's a straight line. Somebody tell me another x value. Any other x value you want. Has to be on our, say that again.
1.
Yes, 1. Thank you. If x is 1, I'm going to plug a 1 in here. -1 minus 1 on my calculator gives me a -2. If x is 1, y is a -2. X is 1, y is a -2. Here's another coordinate, 0, -1. 0, -1 is right here. Do you see this green graph? This is the green graph, is only good when x is less than 1. That means it's on the left side. So I'm only going to the left side, less than 1. When I connect the dots, it should be a better straight line than that. But there's my straight line, connecting the dots and going there. Now, there's something I did wrong. I'm going to show you at that, well, sorry. At this particular point, at -1, wait, what do we get? Wait, I'm sorry. As soon as I erase something, I lose everything. Let me put the dots there again. 1's at 0, -1, 0, -1. 0, -1 is right here. And 1's at 1, -2. Here's 1 and wait. Is that right? Did I put the dots in? Yes. 0, -1 is right here. And 1, -2 is right here. Did I put the dot in the wrong spot last time? X is 1, Y is -2. But at -2, at this dot right here, now if I connect the dots, this is what the graph looks like. You see, I got to connect the dots. It goes that way and it goes this way. But it can't cross this line because the graph, the green graph, has to be less than 1. It has to be on the left side. So this is no good. So this is what the graph looks like. This is what the graph looks like. However, look what I did right here. It's an open circle. This one is closed because there's an equal sign on the blue graph. There's an equal sign in the original. That's why it's closed. But here, there's no equal sign when we get to the 1. It's an open circle at x equals 1. So you have to do both of these t-tables. All you need is 2 dots. Connect the dots, but you have to stay within the boundaries. So this blue graph, the blue graph has to be greater than 1. It has to, the blue has to stay greater than 1. Here's 1. The green graph has to stay less than 1. And so that's what the graph looks like. With all this other mess gone, the graph look, and the red line isn't there normally either, but that's what the graph looks like. All right, we got one more. I don't know if I'm going to do this next one. We'll see. I'm going to do it. I'm going to do it. So you see 0 is our boundary. So I'm going to put my little x equals 0 goes right down the center. It's supposed to go right down the center. X equals 0 is right down the center. So x is less than 0. This is the graph on the left side of the line. X is greater than or equal to 0. This is the graph on the right side of the graph. Left side and right side. I'm going to do the first graph in blue. This one here. This is a y equals 6x plus 2. Somebody tell me an x value I need to plug in. Any x value?
0.
Yes, always start with 0. I was going to yell if you didn't say 0. 6x plus 2. If I plug 0 in there, 6 times 0 is 0 plus 2, I get 2. 0, 2 is a coordinate. Right here. Oh, I got to do it in blue, sorry. And then another one, plug any other number in there. And I'm just going to plug x1. 6 times 1 is 6, plus 2 is 8. So I got a 0, 2, which is a dot right here, and a 1, 8. If I connect the dots, I get this. If I drew it straighter, this is what the dots would look like. Now, remember, this graph is only on the left side of the red line. So I only do the left side. It's on the left side of the red line because the 0 is the crossing point. The next graph, this one, I'm going to do it in dark green. Y equals 2x squared minus 2. Remember, x squared graphs, y equals x squares are parabolas. They're U-shaped graphs, and I'm gonna try to do something. Start off by putting an x0 in there. If I put a 0 in there, 0, 2 times 0 squared, all that, I get -2. I'm gonna try another number, 1. If I plug this into my calculator, 2 times parentheses 1 squared, I get, if I plug 1 into the x value, I get 0. If I plug 2 into the x value, I get 6. So I get 0, -2, 1, 0, and 2, 6. Do you see it's a U-shaped graph? It's hard to do it, but it's a U-shaped graph that looks like this. And the bottom one has the equal sign. The bottom part has the equal sign, so it's an open, the bottom one has the equal sign. So, oh, at 0, it has an open circle. This one, oh wait, this one has the equal sign, so it's a closed circle right there. This one has an no equal sign, so it's an open circle. You don't fill it in. So there's our graph. That's what our graph looks like. You can't have 2 filled in circles because only one of them have an equal sign. Only one of them has the equal sign. Those are called piecewise functions. They're tough. People usually, make sure you practice those. People usually miss those, but I mean, if you know, especially if you give an x value, you have to plug it into the correct function, whichever one it works. And the right side, the domain for the x, tells you which one you should be using.